Good morning, you guys. We're going to be talking about tires and wheels and balancing and a number of things like that. First, let's talk about tires and their construction, okay? So first is bias ply tires. That was an old school type tire that didn't have any steel belts in it. It was used on cars up until the 60s and so on and so forth. Then we had what's called bias belted and then radial. Okay, so bias belted were had belts in them, but then the way they designed them and put them together was in a fashion that we call radial for modern tires, and so everything is steel belted radials now. I'm not going to spend any time with that. You watch the mycareertech.com. They talk more about that. So vehicle tire for a passenger car is what we call a P tire. A light truck will be designated as an LT. And there's some really good tire info at this website. And fortunately, you can, if you're really interested, maybe take a picture of it with your camera. But it has some really, really good tire information that you can get to look at. There's lots of really interesting stuff. There's more to it than you might expect. But when we're talking about tire sizing, we're either looking at a P tire or an LT tire. Sorry if I can get my finger over here. An LT, which is light truck. The basic difference is the light truck tires are going to have a different sidewall construction that's more rigid and strong to handle more weight. They're going to have what we call an E rating for the sidewall. And if you look at this tire here, I'm going to show you. I can grab a tire here and pull it over in front of. Well, actually, I'll just take the camera over here. If you look at this tire here, and we get its reading there, it's a 185/70 R13. Okay. It should be a P in front of this one. This one doesn't show it there. This one's not showing it either. This one's a 195/60 R15. It's not showing that, but there is some load rating specs on the sidewall, and unfortunately, a lot of these are kind of rubbed off from wear, so I won't take any more time trying to find that one there. So it says tread. Looks like 3-ply polyester, 2 steel sidewall, 1 polyester. So anyways, we didn't really see much of anything in the way of P-metric or LT. Let's continue here. So types of tires, well, brands of tires, whether it's Michelin or Yokohama or Kumho or Falcon or Bridgestone or different types of tires. A lot of that's going to depend on your experience. My experience is Michelin, though it's kind of an expensive tire. You pay for the name. They really do seem to outlast a lot of other tires. But there are others. Anyways, let's keep going here. So how are you going to use the tires? Is it going to be for all season? Is it high performance for cornering? Do you have an FRS? Like Marcus or somebody. But what kind of use is it going to be? Is it really going to be an off-road tire, etc.? So you want to kind of think about that when you buy a tire. Tread design of a tire thinks about or considers these: gas mileage. So a less aggressive tread is going to give you a smoother rolling tire. It's going to give you better gas mileage. How's the tire handle? Is it a sticky tire, a soft tire, so it sticks to the road and handles well? How comfortable is the tire? Does it have a tight tall sidewall or short sidewall? The taller the sidewall, there tends to be more flex in the tire. The shorter the sidewall, the more rigid, but the more more performancy and better handling. How about road noise? So if you got a real knobby tire for off-road use, it's going to be really, really noisy going down the road. Just ask Gage Fraser. Traction. If the more aggressive the tread, the knobbier the tread, the better traction the better it's going to do in off-road conditions like mud, etc. Okay. So here's how we size tires. So an example is a P185/80 R13, and you can see in the picture here. Sorry, up here. P is the passenger car tire. 185 is the width in millimeters. 185 millimeters, as it says right there. So the sectional width, which is sidewall to sidewall, that you can see right here, sidewall to sidewall is 185 millimeters. And the aspect ratio is a ratio between the sectional height and the sectional width. And that number in this case is means that 85%, the height is 85% of the width, or this tire has a 75 aspect ratio. That means the height of the tire is 75% of the width. When you get, the original Dodge Viper tires were P335 35ZR17, so 335 millimeter sectional width, so a really wide tire. It was a 35 aspect ratio, so the height was 35% of the width, so it was a pretty short, low-profile tire. And it was a Z rated, that was the speed rating, it was a radial, and it was a 17-inch rim. Well, now we've got crazy 21-inch and 24-inch rims because it's the in thing to see all that metal and not see much tire sidewall, okay? Radial tire just talks about its construction, of course. The rim diameter here, it's a 14-inch rim here. That's the diameter of the rim in inches. So if we take this camera and we look down over here at this four-lug steel rim, we're going to measure the rim diameter. Goes from the bead seat here to the bead seat over here. If you put a tape measure across, it's 14. Don't measure out here on the extreme end. That's going to be slightly larger, but from the bead seat there across to the bead seat over here, that's going to be our dimension in inches. And so you can see that on some of these ratings we've got millimeters and some we've got inches. I don't really know all the backstory for why they've mixed the two measuring systems up, but that's how we do it, okay? Wheel sizing. So the rim width is bead seat to bead seat in inches, we were just talking about. The rim diameter is given in inches, so that's the example I gave you was a 14-inch rim. Back spacing. So what is back spacing? So back spacing is what we call flange seat to outer rim edge. So let me show you the back spacing on this tire. And there's a wheel offset is an associated dimension. So back spacing is the dimension from the rim flange in here. Let me put the camera like this. So from the rim flange here to the outside edge of the tire. So the more back spacing is, it puts the front of the tire out. So a tire with lots of back spacing is stuffing the wheel underneath the car more, and the front of the wheel is out here. So modern cars today use lots of back spacing because we think they look cool. So for example, this wheel has tremendous back spacing. So wheel offset, so from here to here is back spacing. Sorry, let me back out a little bit. From here, from the flange where it hits the axle to the back edge of the rim, that's back spacing. Wheel offset, as I'm going to put this up here, goes from the, as I drop things and throw the camera around, here we go. Wheel offset is associated to back spacing. We call it setback or offset. And that's from the flange seat to the rim center line. So that would be, again, here's the flange here where it hits the axle. So from here to the center line of the wheel is what we call wheel offset. All right. So two different ways of basically looking at the same thing, back spacing or offset. Let's keep going here. The drop center of a wheel is used for tire removal and installation. So here's the drop center. If you just turn the camera down here, you can see the drop center. So you'll notice that the center deep part of the rim here, sorry, right here, is biased to this side right here. So that means when you install the tire, we're going to put it on and off on this side and not try and take it on and off on this side. So they just drop the center to one side. By the way, you can see the big spot welds where they spot weld the center piece of this wheel to the outer piece of this wheel. This is a steel wheel, very cheap construction, very, very easy and fast for them to make on the assembly line. Doesn't need to be very true. An aluminum wheel like this one is a lot truer, and if it's a billet aluminum, that means they started with a block of aluminum and machined it into a wheel. This one, I'm assuming, is a welded rim, but let's see. I can't see. I'm sorry. It's cast. This is a casting. So this wouldn't be this would not be a billet wheel. It's a Jeep wheel. You can see, by the way, there's a weight right there. And let's see if there's any tape weights on the inside. No tape weights. Okay, so just hung an external weight on the outside for wheel balancing. But let's keep going here. Okay, next is a number of lugs and lug hole spacing. So the steel wheel there is a 4 lug, and the other one here is a 5 lug. So there's the 4 lug, 4 holes. And the spacing goes like this. They draw a line through this one. They measure from this line up to this line, okay? On this one, they measure from this line up to the center of this hole, and that's your wheel spacing. So from this line across here up to the center of that hole. But that's a 5 lug. And so just because you have 5 lugs doesn't mean any wheel fits. You have to have a 5 lug with the right spacing. So you can have 4, 5, 6, and 8 lug wheels. 8 would be truck. And then common lug hole spacing is 4.5 inch or 4 3/4 inches, etc. I'll show you a chart here. Let me just pause and grab the chart. So this is a really cool chart put out by the Tire Rack. It has all kinds of information on it. So they've got different tire markings here. They're talking about speed ratings here. Here we've got rotating tire, different ways of rotating tires. Here we're looking at the tire contact patch. Sorry, let me come over like this. The tire contact patch here. And then here they're showing you different dimensions of wheels. And then down here they're showing your lug patterns. And they're showing you, for torquing, they're showing you wheel offset here. They're showing you how you measure the bolt circle depending on the number of bolts that you have here. So that's kind of a cool chart. This is from the Tire Rack, and they give us a lot of detail that is really helpful to us. And we're looking at tires and tire information. Okay, let's continue on. So next is tire ratings. So what's called the UTQG, or Uniform Tire Quality Grading, which is a federally mandated rating. It consists of three things: tread wear, traction, and temperature. Tread wear, traction, and temperature. You can see it right here in the picture there, and you can actually see where there's traction and temperature up there. Tread wear, traction, and temperature on the sidewall of the tire. You usually only find it on one side of the tire, is my experience. Tread wear is going to go from 100 to about 600. 600 be the longest wearing, 100 being the lowest wearing. If it's a fairly high mileage tire, it's probably going to be a 600. If it's a sticky performance-y tire, it's probably going to be a 100. I'm looking on a tire here, and I just found the UTQG. Let's see if you can see it on the camera. So there it says tread wear 360, traction A, and temperature B. Temperature and traction are both ABC, which you're going to see here in just one second when I bring it back up. Let me get it to focus. One sec. There it goes. So traction is A, B, and C. A being the best, C being the worst. And same with temperature, A being the best, C being the worst. Let me go back to that. Okay, so just because it has a low tread wear rating doesn't mean it's a cheap tire. In fact, performance tires all have low tread wear ratings because they're a sticky compound. They're meant they're meant to stick to the road and go fast around corners. But therefore the tread wears out quick. Okay, so let's continue here. So next is what's called the TPC, or Tire Performance Criteria. An example is 80W, where the 80 is a load rating that has to do with how much weight the tire can handle, where the W is a speed rating. And the speed rating is given as a certain miles per hour that tire can sustain for 30 minutes. So on the speed ratings, a W rating on the Tire Rack is a W is 168 miles per hour. They say this thing can sustain for 30 minutes. Just double checking here. Yeah, is what it can sustain for 30 minutes. And then it starts to overheat, and they say that it could separate. So they tell you don't go any faster than that for any more time than that. So speed ratings are either before the R or in the tire pressure or the tire performance criteria. So these ratings change, but S is 112, and you can see a little chart there of different ratings. Yeah, if you got the Z rated tires, you go 149 plus, you're styling, dude. So talk a little bit about maintenance. So we want to rotate our tires every other oil change or every 6,000 miles, and more with all-wheel drive cars that are really sensitive to having tires worn differently. A lot of us are starting to rotate our tires every oil change at 3,000, but as long as you get them every other oil change at 6,000, that's pretty good. Okay, and you'll keep them wearing well. Front wheel drive cars are the hardest on tires, and they tend to wear tires out really pretty quick. So we can rotate front to back. We can do a rearward cross for rear-wheel drive and four-wheel drive, or all-wheel drive. That is, we cross the rears to the front, bring the fronts straight back to the rears. A forward cross for front-wheel drive, we cross the fronts to the rear and bring the rears straight forward. Air pressure. So there's how we typically wanted to rotate. And by the way, front to back is when we have directional tires. That's when we just have directional tires, so we can't switch them to the other side of the car. Otherwise, we're going to use a rearward cross for rear-wheel drive or all-wheel drive, and a forward cross for front-wheel drive. Air pressure. We're going to go 10 to 15% less than the max listed on the sidewall. You can consult the driver's door as well, but it's always going to be less than that. I go by the manufacturer's recommendation on the sidewall of the tire, because they're the ones that made the tire, and the car didn't come with those tires usually from brand new. So 10 to 15% less than the max listed on the sidewall of the tires, the best rule of thumb, to keep the tread wear wearing evenly, to give you decent traction and to give you good gas mileage. But you'll get even wear. If you over pressurize the tire, it gets domed in the center, you wear the tire in the center of the tread. If you underinflate, you tend to wear on both shoulders, okay? So we want a nice compromise between, and we're gonna get a modest amount of engine wear. We're gonna get a modest amount of engine wear, tire wear with good traction and good gas mileage. Wow, okay. So as of 9/1/2010, federal law requires adjusting air pressure on any car coming to a shop. If a car comes into a shop, you have to check and adjust the tire pressure as of 9/1/2010. We recommend checking tire pressure every month, and typically a tire would lose 1 to 2 pounds a month if it doesn't have any kind of a leak in it. If you put nitrogen in the tire, it has a larger molecule that doesn't lose air as fast because it won't leach through the rubber. So car collectors always put nitrogen in their wheels so that their tires stay inflated well. It's just a bigger molecule than normal air, which is 79% nitrogen and 21% oxygen. So just giving it more nitrogen gives it a larger molecule, so it won't leak as much through the tire. Wear indications. Okay, so side wear. So when you get side wear, you've either got camber or toe wear, or you can just say it's worn on one side, we've got some sort of alignment problem. Okay, it could be camber, it could be toe, but we'll talk about that in alignment. Right front outside shoulder is going to be toe out, and left front inside shoulder is toe in, and this is at first. But what you'll find is as you wear, both tires will wear toe in on the inside shoulder and toe out on the outside shoulder, but the right front is where it shows up first with toe out. The left front is where it shows up first with toe in. Cupped wear is where the shocks are bad and the tire's bouncing on the road, and I do have one of these that I believe perhaps I've shown you before, but here it is. Here's a tire with cupped wear. You can see as you look around, it's like worn here, and there's a little bit of tread here, and then another wear here, so it's cupped. It's going like this. And this is this was on the rear tire of a Toyota Celica with a strut that was bad, and it was bouncing up and down as it went down the road. That's what we call cupped tires. Okay. Um, so if we have both shoulders worn, that's under inflation. This would be under inflation here. It's worn here. It's worn here. And then over inflation is where worn in the center. And tire pressure is really critical on tire pressure can be really critical the wider the tire is. So the wider the tire is, the more effect improper inflation has. By the way, if you get a shifted belt in a tire, it can cause a severe pull. So whenever a car comes in the shop and it's pulling dramatically on the test drive, we always rotate the tires, get the fronts to the back, and see if it changes it, okay? Feather edging is toe, and feather edging is where you'll get a sharp wear. If you look at the tire here, when you rub your hand around it this way, it'll be smooth, and you go this way, it'll be sharp. So the tread will tend to stand up. Now that's true mostly on bias ply tires, but on radial tires it does it too. After a while it will do it as well. Extreme outside edge wear is hard cornering. So yes, mom and dad, if they're on their game, they can tell if you've been driving their car hard, it'll be worn out here, and you can see it right on the very extreme outside edge of the tread. You can actually you'll actually roll the tire on its sort of extreme edge, and you can definitely see hard cornering wear, you stinking teenager, you. Flat spots, if you get a flat spot on a tire, that's because we've locked the tires up, locked the brakes up, and skidded and got a flat spot. And now you go down the road and it's like, wump, 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 because you got a spot that's flat. Yeah, I agree. ABS brakes should take care of this, and usually it does, but maybe flat spots are more a thing of the past, but it is a thing. Some miscellaneous tire notes. Let me pause for 1 sec. Okay, so miscellaneous tire notes. First is the UTQG is federal law by the Department of Transportation. DOT is Department of Transportation. And remember, UTQG is Uniform Tire Quality Grading. That's tread wear, traction, and temperature. Tread wear 100 to 600, traction and temperature ABC, A being best, C being worst. Tread wear bars show when 1/16 of an inch left. Let me show you the tread wear bars on this tire. All cars by federal law have to have tread wear bars. So these are the tread wear bars here. It's this raised section here, 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 and that one's already worn out there. So what a CHP will do when he walks up to your car is if he sees a straight line across those tread wear bars where it's worn, he'll give you a fix-it ticket, not because he doesn't like you, but because he's trying to save your life. Because when your tires are worn like that, down to the tread wear bars, you only have a 1/16 of an inch left, and you're getting pretty bald, okay? Soft tires have low tread wear ratings, but handle well, so they have a sticky compound. We mentioned that. Ask the question, are the tires worn because of their material, or do you have accelerated wear? Tire pressure and rotation are critical to wear. So if your tire pressure is off, you know how it wears. Especially if front-wheel drive cars, you really need to rotate them frequently to reduce wear. Radial tires run cooler than old bias ply tires. Yoo-hoo! Okay, let's talk about balancing. So there's two types of balancing. There's what we call static or bubble balancing, which is balancing the tire wheel combination around the circumference. So static or bubble balancing means there could be a heavy spot here, so we're going to have to put a weight down here. So that's circumferential, around the circumference of the tire. The next type of balancing is dynamic balancing, which is side to side, okay? Side to side balancing. So when we look at the tire, we have a heavy spot here, we may have to put weight on the opposite side, okay? So that's called dynamic balancing or side to side balancing. Our computerized balancer will calculate both static and dynamic imbalance at the same time and tell you which side of the tire to put the weight and how much to put, and then where around the circumference to put it. So we can balance off the car with a computerized machine that does static and dynamic together, or we can balance the tire on the car that balances the hub and rotor and drum combination depending on what you have. So what we like to do is we like to balance the tire on the computerized machine, get the tire wheel combination balanced, put it on the car, spin it up, and then what we're essentially doing is balancing any hub, rotor / drum imbalance. This doesn't really need to be done on anything modern with disc brakes, but if you have an old school car like Anthony Millay with the old Chrysler, that thing's probably like bouncing like crazy and could really stand to have some on the car balancing after getting the tire wheel combination balanced on the computerized aligner. Okay, just a couple of tire pressure monitoring notes. TPMS started in 2007. It was a federal regulation. 100% of cars must have TPMS by 9107. The tire pressure gets 25% below OE specs, original equipment specs. It'll eliminate the TPMS light, and nitrogen causes the tire to run 20% cooler, just some miscellaneous things. Here's some tire pressure monitor sensors. They have a battery in them. The battery is not replaceable. You have to replace the whole sensor to the tune of about $35 to $45, depending on the brand. The batteries last about 10 years, is at least my experience. So starting in 2017, 2018, we started getting all kinds of cars with tire pressure monitor lights on, and now we have to replace those. We have a TPMS 3, Snap-on TPMS 3 that will read the sensors and will also code the sensors. We can also code them with the modus, the Snap-on modus. So we have a number of ways of doing those. So that's a modern repair that we have to do because of this federal requirement. And the reason for that, it was one of an attempt to get us off our foreign dependence on oil, because the better gas mileage we're getting, the less fuel we're using, and so on. And especially with gas so expensive right now, it's kind of nice to have those TPMS monitors working. If you tend to work around a construction site, tend to pick up lots of screws and nails, it's kind of nice to have the TPMS light. Early Toyotas, late 90s, early new millennium Toyotas that started to have TPMS systems. What a pain. Can't get them to go off for anything. It's like an 06 Sienna. Really problematic with tire pressure monitor systems. All right. I think that's it. There you go. All right. We'll talk to you guys later.